Today, over here, you see the VOD, verse of the day. Really more of the verse of the week. Listen, I've told you since day one, I am learning to do this better. I'm trying to bring our faith in here. Praying, yeah, every class does that. The music, yeah. I'm digging deep and trying to figure out how can I do this. It's hard for me. I'm going to lay that out. It's hard for me. So when we get started, we're going to read these because guess what we're doing? Today is the first day of Algebra 2. We are starting Algebra 2. In the beginning, we're going to learn about real numbers. I'm going to bring it back to Genesis, right? Okay, so have to have your books from here on out. You're going to solve, remember, I am not here on Friday. Okay, so I am not going to be here on Friday, but I want you to truly read this, or listen to this. Don't just hear it, but listen to this, okay? So you know exactly what it says. This class is unique because it is all seniors. They're a very cool class. They have energy and spirit. You can tell that God has been working on each of these students' hearts. This class never fails to make me smile, okay? This is in my plans. I want the sub to know how great you guys are. Don't let me down. Okay? Equations are going to be a big part. You will be quizzed again on equations. We did 1-step and 2-step. Listen, y'all, this is a baby equation, like section 1.4 of our algebra book. So I'm letting you know. I gave you the baby ones to build you up to mama and papa equations. So here we go. You have the rules. Check your steps. First step, find your balance point. Step 2, distribute if needed. Do we need to distribute with him? Yes, what?
-2.
Good, stop there. We're distributing the -2. I don't even care about this side right now. -2 multiplied by 3x, -2 multiplied to the +8. I like to circle the number in the sign. -6x, -16. This drops down. I'm still covering this side because step 3 is still talking just about this side, where it says what? It might be step 2 if you don't have the printed out paper. So the printed out paper is step 3. If you just watched the notes and wrote them down, it's step 2. Oh, do we have like terms on this side? What are they? -6 x's and 5 x's. -6's, x's, and positive 5 x's leave me with a -1 x. Remember, I bring down the -16. Did I lose anybody on this side? Here's the beautiful part about equations. You might have done it differently. You might have started over here. I try to get everything that I can on one side done. Now I'm looking at this left side, which means don't look this side anymore. I wish I was bigger. If I was, then you wouldn't be able to see it. But I'm 5'7" on a good day and like 162 pounds. Like, I'm not covering it up, y'all. Okay? So now we're looking over here. Do we need to distribute? No. Can we combine like terms on the same side? Yes. We have 3x's minus 5x's. And notice what I'm doing. I'm bringing it down all the way to match up here. What's 3x's? Take away 5x's. -2. -2x. Okay, now, this is where my rules go a little bit off kilter. Because usually I say, let's move the smaller variable, which is -2, but I don't want to do that. Because the goal is to always what? For any equation, we want to what? Starts with an I, yeah? Isolate, get it by itself. Isolate the variable. We need the x's all on one side. So I don't want to move them towards this 16, which is a what? What's that called? Constant. You're like, I thought you were going to choke. I was like, what's going on, William? Constant, okay? This is a constant, coefficient variable. Let's move it away from the constant. So -1x, but Mr. H, when we move to the opposite side, we do the opposite operation, which is called the inverse. I'm going to add 1x. The reason that this works is this is the additive inverse. Additive inverse always will give me 0. -16 drops down equals -2x plus 1x is negative 1x. And some of you stopped there. You had a little trouble on your quiz yesterday, and you're like, negative, now what? No, it says negative 1 times x. We don't want that. Isolate it. So that means we need to by a negative 1 on both sides. This is the multiplicative inverse. Multiplicative inverse says a number by its reciprocal, negative 1 multiplied by 1 over negative 1, is 1. Negative divided by a negative is positive 1x. Excuse me, negative 16 divided by negative 1 is positive 16. Impress me. Who got that one right? Flex on me. Oh, man. Okay, so then I'll flex. I got it right. Come on. And that's a little funny. What teacher is proud when they get the problem? Let me be proud. I got it right. What questions do you have on this? Okay. So, again, I know that... May I steal your binder? Okay. I know a lot of you have notebooks. What I would suggest is getting a binder. Let me put that up there. That way you can have a section that's just for warm-ups. You can have a section that is just for homework. You can have a section that is just for notes. Because if you just keep going through the notebook, we're going to have a lot, guys. You're going to go through like 2 or 3 notebooks. I'm not lying to you, because math takes up a lot of room, and I give you a lot of notes. Why? Because I want to make sure that you're prepared. Binders are a little bit easier to keep track, because once we're done with something, I can say, hey, listen, you need that, but why don't you take it out of your binder, put it all in one section. Make sense? Okay, so I would suggest a binder. So what I'd like you to do now is start a whole new page of notes. We are doing, I'd put the date up. I would put the section, we are doing 1.1 real number system. May I erase what's on the board? Okay. If I go too fast, you have to let me know. I think you guys will all advocate for yourselves. The verses that I'm going to read will play out a little bit better once we've gone through this section. But we are going to start by saying that mathematics attempts to describe principles and laws created by God using symbolic notation. Okay? We know Genesis 1:1. What does it say?
In the beginning was the Word, and the Word was with God, and the Word was God, I think. Something like that.
Okay, so I'm the New Living Testament, or New Living Translation, or whatever it's called. New Living Translation. Mine does not necessarily say that, but I'm sure that it is. Mine was, in the beginning, God created the heavens and the earth. That's 1:1. In the beginning, God created the heavens and the earth, right? Okay. So, viewing our world as the creation of God, and as ourselves as created in His image. So that's the first one that we're looking at. He created us in His image, where it says, then God said, let us make human beings, us. Let us make human beings in our image to be like us. They will reign over the fish in the sea, the birds in the sky, the livestock, and all the wild animals on the earth, and the small animals that scurry around along the ground. So God created human beings, man, in His own image. In the image of God, He created them, male and female, He created them. The thing that stands out to me is the us, right? And when I first started reading the Bible, that confused me a lot. And I'm going to save that part for your Bible teachers to really go into the theology. I've heard lots of different things about what the us stands for. But we are going to be talking about a set of numbers that all fall under one thing. Jesus, Holy Spirit, God. Father, Son, Holy Spirit. One thing as 3 separate pieces. Not really 3 separate pieces, but all falling under one. Okay? Psalms talks about that, but I really want to go to Hebrews chapter 11, verse 3, where it says, by faith, by faith, we understand that the entire universe was formed at God's command, that what we now see did not come from anything that can be seen. There is a faith that we are trusting God. In math, at some point you have to have some type of faith to say, I know this to be true. Somebody long ago realized God's patterns and said, this is the truth. So some of these things might not make sense, but you have to have a little faith to say, okay, I'm trusting Mr. H to say this is true. Fair enough? Okay. There it is. We are going to use a huge portion of the board. Real number system. If you watched the video last night, you might have taken some notes. Did anybody watch the video and take notes? Yeah? Lydia's like, yeah, I did. Step it up. Step up your game, y'all. Okay. So, real numbers. Guess what? In Algebra 2, we're going to learn something else. There are imaginary numbers. A little crazy, right? This is all real numbers. In these boxes, each thing is going to represent something. So even though I'm putting the word irrational numbers in this box over here, does that still fall under the real number system? Yes, still part of the real numbers. Let's start. Now, wait a minute. If it's in this box, is it part of the real number system? If it's inside the box, it's part of the real number system. Okay, you ready? And I like to do this with my kid, okay? Patrick, you're my child now. You're going to be like Cole. Cole's 6 and he can do this. Don't screw it up, Patrick. You ready? Start counting.
1, 2, 3.
Oh, good, good. William, start counting.
1, 2, 3.
Ava, start counting.
1, 2, 3, 4.
Where do we all learn to count from?
1.
From 1. Does any parent say, okay, little guy, here, I'm a math teacher. I know. Cole, you ready? We're going to start at 0, buddy. Okay, Daddy. That's not what we do. Where do we learn to count from? We learn to count from the number 1. Those have a specific name. What's the specific name? If you watch the video, you'd know this. They are called natural numbers. Oh, wait a minute, Mr. H. You're making a circle inside of a box. Yes, I am. So here's the question. Are natural numbers inside of the box of real numbers? So a natural number is always a real number. Is natural inside the box of irrational? So will natural ever be an irrational? Never. Okay. So natural numbers, another name for natural numbers, are called counting numbers. So what are they again? 1, 2, 3, 4, and they go on forever and ever 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 and ever. And ever 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 and ever. And we'll move on. Okay. So natural numbers are our counting numbers that go on forever. Wait a minute, Mr. H. That kind of looks like a bullseye. Yeah, kind of. There's another name that we need to know. And the name tells me what we're missing. The name now are whole numbers. Whole numbers are almost the same as natural numbers, with one exception. Whole numbers. What number pops into your mind? Don't look at this word. If I just say, it's a whole, what number?
0.
0. 0 looks like a whole, right? The only difference between natural and whole is the inclusion of 0. So now, here's my question. Are natural numbers always whole numbers? Yes. The innermost goes out. A natural number, 1, 2, 3, 4, is always part of the set of whole numbers. 1, 2, 3, 4. So I'm going to give you a number. 2,143,000. Is 2,143,000 a natural number?
Yes.
Yes, we could count to that. It would take us a long time. Is 2,143,000 also a whole number? If it's a natural number, it's also a whole number. What's the only whole number that's not a natural? 0. So if I say, name this one, 0, you tell me it's a whole number. You wouldn't say it's natural. Still with me? Okay. Ooh. Then we have another word that are integers. And integers are whole numbers, except they are the whole numbers and what? Their opposites. Okay? And the reason why I don't want just negative numbers, because I'm going to show you in the next one, there's going to be a lot of negative numbers. So this means that I've got 0, 1, 2, 3, 4, going on forever. What's the opposite of 1? Negative 1, negative 2, negative, what is that? Negative 3, negative 4. And it goes forever in both directions. Okay, here's my question. Is a natural number always a whole number? Yes. Is a natural number always an integer? Yes. Is an integer always a natural number? Not always, sometimes. Give me an example of an integer that's not a natural number.
0.
What?
Is it
0
0?
is an integer, but not natural. Good. Give me another one.
Negative 2.
-2 is an integer. -2 isn't a whole number. -2 isn't a natural number. Okay? Because naturals start at 1 and go that way. Whole numbers start at 0 and go that way. Integers are the whole numbers and their opposites. Which means we're missing one other piece. And they are called rational. Rational numbers are any fraction that you can write. Any fraction. 21/8. 43/116. Any fraction is a rational number. Any perfect square is rational. Oh, but wait. Any decimal that terminates 2 4/10. Any decimal that repeats. -21.121212, and that 1, 2 is what's called repetan. It means it's repeating. Okay, so any fraction, any perfect square, any decimal that terminates, a terminating decimal, any decimal that repeats. So, here's my question, and we're looking at this 36. What's the square root of 36?
6.
Oh, wait a minute. What is it?
6.
The square root of 36 is 6. So square root of 36 is rational. What else is the square root of 36? What did you just tell me the square root of 36 was?
6.
Oh, so it's also natural, which means it's natural, whole, and integer, and rational. The most specific subset for the square root of 36 is not rational. What's the most specific? You told me the square root of 36 is what?
6.
So which is the smallest that we can say it is? Natural. Even though we have it up here in rational. Okay, what about this one? What about -21.7? 21 7/10. -21 7/10. What is it? What? A rational number, because it's a decimal that terminates. So, Mr. H, what about irrational? Well, irrational are decimals that go on forever and non-perfect squares. Your calculators do not do this justice. So right now, if you have a calculator, put in the square root of 39. And you should get 6.2 something, right? 6.3 something? Can you calculate?
I've got one.
Okay.
Okay.
6.2, and then it goes 4499799 and it stops. Okay? Here's the problem. Can the calculator show it going on forever? The calculator has a finite number. If it's a non-perfect square, this decimal goes on forever. It will never stop. Does anybody know another number that never ends?
Is it 9 or?
Huh?
It's not 9, right?
9 would be a natural number.
Okay.
47.
Huh?
47.
Oh, no, I'm not talking about perfect squares. I'm just saying, what term, number that I'm going to be able to write in irrational, that you've dealt with in geometry a lot, especially when we're dealing with circles, what number, it's a symbol, it's delicious,
Oh,
Oh, pi.
pi. Pi is an irrational, I didn't take attendance. I'm taking attendance, I'm sorry. Thank you so much, appreciate it. Bye. Pi is a number. Even though we use it as a symbol, pi is a number. But it goes on forever. And I don't remember where it's at. There's a computer that is physically always computing pi, and it's been doing it for like 38 years, trying to see if pi ends. But it's been going on for 38 years. It doesn't end. Okay? And there are others, but a decimal, like if you just saw 3.123498621 Those dots mean that it's not repeating. It's going on forever. So here's my question. Is an irrational number ever a rational number? No. Never. Is it in the same box? No. Is a rational number ever a natural number? Think about it. Can a rational number ever be a natural number? Sure. Give me an example.
36.
The square root of 36 is a natural number because the square root of 36 is 6. The way this works is like this. This is called my always line. A natural number is always a whole number. A natural number is always an integer. A natural number is always rational. Then we can pick up here. A whole number is always an integer. A whole number is always rational. An integer is always rational. But this direction is called my sometimes line. Is a rational ever a natural? Sometimes, but not always. Is an integer sometimes a whole number? Sometimes. Is a whole number ever a natural number? Sometimes. Okay, because 0 doesn't make it natural. But a natural number is always the others. Notice how there's no lines going over here. Why? Because none of these are ever irrational. What questions do you have? So let's do this as an example. I'm going to give you 2 numbers. So example 1 and 2. You're telling me all of the specific sets it would fall into. Let's go 25 fifths and negative 3.71243 ... Okay. So you're telling me those 2, where do they fall into? So name all of the specific sets.
answer or should?
Can we wait till we go over this?
Okay.
Okay. So, here's my first question. 25/5. Can we simplify it? Because you should always check that first. What is 25/5? Oh, I bet that changes some of your answers. If it is 5, what set is 25/5 in? Give me the smallest set that it can be. It is a natural number, which means it is also whole, which means it is also an integer, which means it is also rational. Always check to see if you can simplify whatever number you're given. What about this -3 and 7, 1, 2, 4, 3, blah, 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 blah. Patrick, what do you think?
Rational.
Does the decimal end? So if it does not end,
Uh,
what's it going to be? Irrational. So if the decimal does not end and it does not repeat, it is irrational. Questions? Okay. Your homework is in the book, page 5, numbers 7 through 14. And numbers 22 through 32. Is that right? Yes, it is. It is 10:42. We get out at 10:55. My guess is you'll have most of it done. Questions, concerns, problems? Okay.